Stoichiometry. I'm Mr. B. Let's begin with the formation of iron 3 sulfate, where the question is, how many moles of sulfur trioxide are needed to react with 144 moles of iron 3 oxide given this unbalanced chemical equation, where Fe2O3 reacts with SO3 to form Fe2SO4 3. First, balance the chemical equation. There are two atoms of iron on each side of the equation, so the iron is balanced. There is one atom of sulfur on the left side and three atoms of sulfur on the right side, so place a coefficient of 3 in front of SO3 on the left side of the equation. Now the equation is balanced. Next, write the molar ratio, which is 1 to 3 to 1. This is a synthesis reaction where A plus B yields AB. Now moles of SO3 can be calculated. First, create a fraction from the molar ratio. The coefficient of the unknown moles divided by the coefficient of the known moles, where the unknown is X, which is SO3, and the known is check, which is Fe2O3. So the fraction will be 3 over 1. The calculation is completed as follows, where 144 moles of Fe2O3 is given, and we're looking for the number of moles of SO3. So we write the following: 144 moles of Fe2O3 times the fraction, 3 moles of SO3 divided by 1 mole of Fe2O3. This is equal to 432 moles of SO3. Notice that the moles of Fe2O3 will cancel. Now for the reaction where thioformaldehyde reacts with fluorine gas. One way to make sulfur hexafluoride is to react thioformaldehyde, CH2S, with elemental fluorine. If 45 moles of SF6 is produced, how many moles of F2 are required, where SF6 represents sulfur hexafluoride? First, balance the chemical equation. There is one atom of C on each side of the equation, so therefore the carbon is balanced. There is one atom of S on each side of the equation, so sulfur is also balanced. There are 2 atoms of H on the left side and 1 atom of H on the right side. So place a 2 in front of HF, hydrogen fluoride. There are 2 atoms of fluorine, F, on the left side and 12 atoms of F on the right side. So we must place a 6 in front of the F2 on the left side. Now the equation is balanced. The molar ratio will be 1 to 6 to 1 to 2 to 1. Now moles of F2 fluorine gas can be calculated. First, create a fraction from the molar ratio, the coefficient of the unknown moles divided by the coefficient of the known moles. The unknown is F2 and the known is SF6. So the fraction will be 6/1. Now the calculation is completed as follows, where 45 moles of SF6 times the fraction, 6 moles of F2 divided by 1 mole of SF6. The moles will cancel, and the answer is 270 moles of F2. This concludes my explanation of stoichiometry. I'm Mr. B.